In this lesson, we're going to look to combine the ideas of probability from last unit with our ideas of counting from this unit. So to refresh, probability means we want the ways something can happen, our specific event, out of all the possible ways something can happen. The challenge this time is we're going to have to be able to count those different things. So we're going to basically do a bunch of examples today, different counting techniques that we've learned in this unit so far. Start the first one here. The probability of flipping 5 coins and having them all land on heads. Okay, so it's probability, not just counting. So we're going to start with P of A. How many ways can we have them all be heads? Well, there's only one way. They all have to be heads. How many different ways can we flip coins? Well, for each coin, there's 2 choices. So 2 and the second coin, 2, and the third coin, 2, and the fourth coin, 2, and the fifth coin, 2. Or in other words, 1 over 2 to the 5, which you can simplify as 1 over 32. Okay, so that's one of our basic counting techniques, the idea of AND. And second example here, we have 4 people in line at Starbucks. The probability that they're lined up in descending order of age. So our probability. Descending order of age means from oldest to youngest. How many ways can that actually happen? Well, there's only one way that can happen, oldest to youngest. But how many different ways can we line up people in a line? Well, if there's 4 of them, we're going to have 4 factorial. There's 4 choices for the first spot, then 3, then 2, then 1. Or in other words, 1 out of 24. And just point out we're defined as fractions or decimals or percents when we talk about probability again. Try the next one. Committee must be formed. What is the probability that Bill will be the president and Jill be the vice president? If the president and vice president must be chosen from a board of directors that has 8 different members. So what do we need here? Probability. I need Bill to be the president and Jill to be the vice president. Well, there's only one way it can happen. Bill has to be the president and Jill has to be the VP. Anybody else is in those roles, that's not what I want. How many different ways could I pick a president and a vice president, however? We've got 8 different people to choose from, and we've got 2 different jobs that have to be filled. In other words, positions. Well, that's a permutation. Or if you will, how many ways can I fill the first spot? 8. And the second spot, 7. Okay, so 1 out of 56. Let's try some more examples. What is the probability of getting a Yahtzee? That is, all 5 of the dice are the same number. So what could we get? Well, I could have 5 dice that are all 1s, or all 2s, or all 3s, or all 4s, or all 5s, or all 6s. There's 6 different ways of getting something that's all the same. And how many different ways can I roll each of those dice? Well, there are each 6 different ways, and 6 for the second, and 6 for the third, and 6 for the fourth, and 6 for the fifth, or in other words, 6 to the power of 5. We could simplify that to 1 over 1296, or if you want to, that's the unsimplified answer. Okay, these all take a little bit of practice. They're all kind of the same, but they're all kind of different from each other too. Let's take a look at the next one. In a track meet, we have 5 entrants of equal ability. What's the probability that the finish will either be in descending or ascending order of age? So we've seen something like this where we had descending and ascending before. We did descending at Starbucks. And we said there's one way to do that. Well, if we put in descending or ascending, now we have 2 choices. They're either smallest to largest or largest to smallest. And how many ways can we line up 5 people in a row? Well, we know that's a factorial. So we get 2 over 120, or if you want to, 1 over 60. How about the probability that Sandy will be first? Well, in this case, we're looking at how many ways can we finish in first place? How many different possibilities are there? Well, for Sandy to be first, she has to be first. There's only one choice for that. And how many people could finish first? There's 5. 1 out of 5. Okay? This is a very basic counting technique this time. How about Shannon first and Sandy second? So now we're looking at 2 spots, Shannon and Sandy. Well, I need it to be Shannon and then Sandy. Again, there's only one way to do that. Shannon's first, Sandy second. But how many different ways can I fill these first 2 spots? 5 people, and we got 2 spots. So 5 P2, or in other words, 1 over 20. Okay, last one here on this question. Sandy and Shannon run in adjoining lanes. In other words, they're side by side. Now, again, we've done something like this where we had to put things side by side. We know that we have these 5 spots, but we need Sandy and Shannon to be together. So we make them into a group, which leaves us one group plus the other 3 spots. So we have 4 factorial ways of doing this. Oh, sorry, I was in the wrong spot there. 4 factorial ways of doing this, but we don't know if it's Sandy then Shannon or Shannon then Sandy, so the group itself has 2 factorial. And remember, our question is just that they're in adjoining spots. We're filling all the lanes. How many ways can we do that? 5 factorial. So on top, we end up with 48. On the bottom are 120. Or if you want to reduce that, you can say 2/5. Okay, last one. This is kind of a classic question that you often see in math books. Okay, there's 22 students in this class. What's the probability that no 2 students have the same birthday? We call this a birthday question. To do a question like this, to figure out the probability they don't have the same birthday, let's do the opposite. Okay, let's figure out what's the probability of having 22 different birthdays. Because if I know the probability of different birthdays, the complement to that would be the probability they have the same birthday. Someone shares a birthday. So I need to pick out 22 different birthdays. How can I do that? Well, I've got 365 days to choose from. And I need 22 different days. In other words, I need a permutation with 22 different objects. That's 22 different days. Now, each person has a choice of 365 choices for their birthday. So I've got to make this out of 365 to the power of 22, because there's 365 choices for the first person, and 365 for the second person, and 365 for the third person, and so on and so on and so on for 22 people. If we do this math, we get 0.524. So if I want to know the probability they share a birthday, that's different birthdays, what's probably they share it, a shared birthday would be 1 minus the different birthdays. In other words, 1 minus 0.524. So there is a 0.476, 47.6% chance that someone in this class has the same birthday as someone else. It's surprising. The bigger the number, not that it has to be a really big number, even a class of 30 or so, you have more than a 50% chance of somebody sharing the same birthday, which people often find surprising. Okay. Today was basically example-based because we need to try some of these things. We're combining ideas, permutations, factorials, counting with probability. Okay, we're going to try the homework, which apparently I didn't put on the thing there. We'll put it in right now. Okay, your homework is going to be on page 93 today. We're going to try, put it on here right now, these questions. And I'm going to give you a bunch because we need to practice these ones. 7 to 9, 13, 14, 16, A, and 19. If you're stuck with some, come see me. We can try them together and figure some stuff out. And then that's the end of this unit. So we're going to do a review and then a test, and then we'll be done.